Let's look at solving a problem from the textbook. Complete and balance the following neutralization reaction. So pause the video and see if you can complete this reaction. So hopefully you identified the first reactant, HNO3, as nitric acid and a strong acid, and the second reactant as potassium hydroxide and a strong base. And as we know, the reaction of a strong acid and a strong base will form water and an ionic compound, which we call a salt. So the formula of water is straightforward. That's always H2O, and that's formed from the hydroxide of the base and the proton of the acid. What might be a little bit more of a challenge is figuring out the formula of the ionic compound or salt. So it is important to know the charges of the cations from the base and the anion from the acid. So potassium always has a +1 charge, hydroxide always has a -1 charge. Nitrate has a -1 charge, and you can find nitrate in the list of polyatomic ions, table 3.2 of your textbook. So looking at the charges, potassium has +1, nitrate has -1. They will form a compound in a 1-to-1 ratio. And when we write the formula of an ionic compound, the cation always comes first. So the positively charged ion always is first. And since there's 1 proton in the acid, 1 hydroxide from the base, we form 1 water molecule. And there's 1 potassium and 1 nitrate, 1 potassium nitrate. So our equation is balanced. So now let's take a look at sample problem 9.3. Complete and balance the following neutralization reaction. So pause the video and see if you can determine the products here. So hopefully you identified HBr as the strong acid, hydrobromic acid, and calcium hydroxide as the strong base. And we know that anytime a strong acid and a strong base react, we get water as well as an ionic compound. So to figure out the formula of the ionic compound, we know that calcium as an alkaline earth metal has a +2 charge, and bromide has a -1. So we need 2 bromides for each calcium. And we know that the hydroxide is going to combine with a proton to form water. Now, we actually have 2 hydroxides from calcium hydroxide. So we need 2 protons. And when I look at the salt that forms between calcium and bromide, CaBr2, I need 2 bromines on my product side. So I put a coefficient of 2 in front of HBr, and that will help balance my bromines, and it will also give me 2 protons to react with the 2 hydroxides from calcium hydroxide. That also means that I will have 2 water molecules. So when we balance our chemical equation, we want to make sure that our formula is based on the charges of the cations and the anions, and that each hydroxide has 1 proton, and for each hydroxide and each proton, you will form 1 water molecule. So 2 hydroxides need 2 protons and will form 2 waters.